Welcome everybody. We're doing the acid-base buffer pre-lab calculation. And so you won't see me, but I see you. Here's how this works. There's two parts. There's an acid buffer and a base buffer. And this is in your lab manual. And here's what you do first. First you're going to find the volume that you need of the 2.5 molar stock solution of the sodium acetate. You're going to use the dilution formula M1V1 equals M2V2 to do that. Then once you find that, you're going to go straight to the Henderson-Hasselbalch. You're going to solve the Henderson-Hasselbalch for the acid. You're going to have, you'll know pKa, that's 4.74, and you have an assigned pH. This 0.2 is the base concentration from before, the 0.2 molar. You're going to solve for that, and then in this next step, once you know that, you're going to find the volume of the 6 molar acetic acid that you need to add. That's going to be a liquid, so again you'll use the M1V1 equals M2V2. And this is your answer from part 3. Okay, so you found the acid concentration just above. And that's it for the acid part. Now, for the base part, that here starts on our part 5, step 5 here. You have an assigned pH of your basic buffer. What you're going to do now, this one is mass. So you have to do a couple more conversions, but it's the same idea. First, you need the mass of the sodium hydrogen carbonate needed. So you can do a little conversion, convert to moles, get rid of the liters, and then to grams. And this will be the mass that you need, and you're going to weigh that out in lab. Then you're going to have to find the concentration of the sodium carbonate. And that, just like in the above problem, you're going to go straight to the Henderson-Hasselbalch. You're going to solve for the base, which is the carbonate ion concentration. And you're going to use Henderson-Hasselbalch, the assigned pH minus the pKa. The pKa is a given number, you'll see it right there. And the 0.1 from the hydrogen carbonate ion, that's from above. So then the last step, once you find the concentration of carbonate ion, you're going to find the mass of the sodium carbonate that you need. This is the answer from the previous part. That's a concentration. Multiply it by the volume to get to moles, and then multiply by the molar mass. And you'll have the mass of the carbonate you need. Pair that with the mass of the sodium hydrogen carbonate, and that's what you're going to use to generate the basic buffer in lab.